Alright guys, this is it. This is the last section ever. We're gonna be done. The last section here in chapter 17 is about amines and amides. Amines are derivatives of ammonia, NH3. So they contain a nitrogen, and then attached to the nitrogen are one or more alkyl groups or aromatic groups. So we have methylamine, where we have a methyl group replacing one of the hydrogens in ammonia. If we have two methyl groups, then we have what's called dimethylamine. So here are some of the simplest amines. So we can see here we have ammonia, NH3. And then attached, if I substitute one methyl group for one of the hydrogens, then I get what we call methylamine. If I substitute two methyl groups for the hydrogens, I get dimethylamine. And if I substitute three methyl groups, then we get what we call trimethylamine. So they have one or more carbon atoms bonded to that central nitrogen atom. Aromatic amines use the name aniline, which is approved, which is an IUPAC name, not a common name. So aniline is the name for an aromatic group attached to the nitrogen. Aniline is used to make fabric dyes, including indigo, which we use to dye blue jeans. This is the structure of indigo, but we can see here's the amine group. There's actually two of them in this structure. Looking at amines, giving the common name for amines. So I've got here two carbons attached to the nitrogen. So then this one would be known as ethylamine. And then here I see I have 1, 2, 3 methyls attached to the nitrogen. So this would be trimethylamine. So those are the common names. Here we have a couple more. Looking at the line angle formula for the first one, I see one carbon here, so that's a methyl, and then I see 1, 2, 3 carbons, that's a propyl. So we would name this methyl propyl amine. Looking at the second one, I have 1, 2 carbons, that's an ethyl. Here's 2 more carbons, that's another ethyl, and then a methyl. So we would call this diethyl methyl amine. The second functional group we're going to talk about today are called amides. And amides are derivatives of carboxylic acids, which we talked about previously. So here we have a carboxylic acid, acetic acid or ethanoic acid. Here's our carbon, here's our carboxyl group, and here's our hydroxy group, making that carboxylic acid functionality. In an amide, in an amide, the OH group is replaced by an NH2 group. So we change the OH to an NH2 group. Amidation is when we take a carboxylic acid and react it with ammonia or another amine, and the OH from the carboxylic acid reacts with one of the hydrogens from the ammonia to make water, and then the two molecules bond together. So showing amidation, or the result of amidation here. I'm going to draw the formula for the amide formed in a reaction between ethanoic acid. Here we have ethanoic acid, and here we have ethylamine. So we're going to see that the OH group and one of these hydrogens is going to come together to make water, and then we'll bond the rest of it together. So then we come up with this. Here's the ethanoic acid part, here's the ethylamine part, and they're bonded together. When naming amides, we take the IUPAC and the common name both, and we start with the carboxylic acid name and add the suffix amide. So we take off the IC from the carboxylic acid name and add the name amide. So looking here, I have 1, 2, 3, 4 carbons. That's butanoic acid, or butyric acid is its common name. So then it's butanamide or butyramide would be the common name. So we've got methanamide, ethanamide, and benzamide as also their IUPAC names, and then their common names are in parentheses after that. So looking here, giving the IUPAC and common names for this compound, I see I have 1, 2, 3 carbons. That's propane for 3 carbons. As a carboxylic acid, that's propanoic acid. So then we change that. We change the IC ending to the amide, and then we wind up with propanamide, or the common name propionamide. Remember, those first 4 carbons have those common names as well. So looking here at what maybe their names might be. So I've got 1, 2, 3, 4 carbons. So that starts with butanoic acid. So with a 2-chloro. So then we change the IC acid to amide. So this would be a 2-chloro butanamide. Then looking at this one with 2 carbons, the IUPAC name would be ethanoic acid, if it was a carboxylic acid. Now that it's an amide, so we've just changed the IC acid part to ethanamide. And those will be IUPAC names. Common names are they're available as well. And that's it. That's the end. No more chemistry for me.